Hi, in this video we're going to find an approximation for the alternating series that I have up here that has an error less than 0.000005. Now what that means is I'm trying to find the partial sum, or how large does n have to be so that the partial sum and the true sum differ by no more than that error. First thing I want to do is write out what that sum looks like. It's alternating, so you go from B1 and then minus B2 plus B3 and so on all the way up to your Bn here, and then you just keep going because it's the true sum, so this would go on forever. Now this part here I'm going to call Sn, and then this part here is Rn, so I'm going to put those right there. Now this part up here is my nth partial sum, and then this is the remainder term. This is the term that I want to estimate. I want this to be small so that my partial sum and the true sum don't differ by that much. Now, one of the biggest things to notice with alternating series is that the sum, or I should say, the sum, this sum right here, can be no bigger than B1. Because what's going to happen is after you find B1, you're just going to keep adding and subtracting off smaller numbers. So the sum, the overall sum, can never be bigger than B1. Now over here, the remainder, now you can treat this as a series as well. If you were to add up all of these terms, just like the overall sum, if you were to add up these terms, it can be no bigger than this term right here, the Bn plus 1. So I can write that like this. We're looking for the term, the Bn plus 1, so that that term is less than my error. Alright, so I'm going to just rearrange the problem here so the question's up here. So I'm going to start going through all the b values in the sequence and find one that's smaller than this. So let's start with b1. Alright, pull out your calculator, and I already typed it in and I got 0.1, so my first term is 0.1. That's definitely less than, or it's not less than, the error, so I have to keep going. Find B2, take out the calculator again, type it in, and we get 0.005. Again, that's not less than the error, so we move on. Find B3, pull out the calculator, there's my number, put that in, still not less than the error, so we'll go on to B4, plug it into the calculator, get a number, still not less. It's getting closer, but that's still not less than the error. So look at B5, type it in, and that's what we get for that term. Notice now B5 is less than the error. So this is the term that I want to actually exclude from the partial sum because it doesn't matter. Now because B5 is the term that I'm excluding, I actually only want n equals 4 terms. I want up to S4. So I'm going to take B1 minus B2 plus B3 minus B4. Now if I actually evaluate that with the terms that I had a few minutes ago, this is what I'm going to get for the partial sum. Now the actual sum, rounded to the same amount of decimals, looks like this. You can actually see the numbers are actually good up to 6 decimals worth, and then they're off at this point right here, right? 1, 2, 3, 4, 5, 6. So they're off on the 7th decimal. If you subtract the true sum from the partial sum, you get this value, and this is my error, and that is less than 0.00005.